I came up with an initial idea which turned out to be wrong. It wouldn't work several years ago, and then but I sort of shot my mouth off and said, oh, I thought I have an idea that would work, and it turned out that didn't work. But with a lot of iteration, was able to come up with something where the physics hangs together, and then published the paper and just said, like, look, anyone who wants to do this is great. Go, be my guest, because I sort of have my plate full running Tesla and SpaceX.
Yeah, yeah.
And so I think it'd be great. I mean, it'd be great to have any interesting new transport solutions, anything that gets people to their destination in a way that's safer, costs less, is more convenient. That'd be great. I mean, and so I think probably the most valuable thing that the Hyperloop paper that I published has done is to spur thinking in terms of new transportation systems. So it's not just, oh, let's have a fast train. Okay, that's not even as fast as what Japan did in the 80s. Like, okay, well, I don't see what the point of that is. Like, we should really be trying to think of something that's, I think particularly in California, like, we should be like saying, hey, what is the best? Let's invent something new that's way better than anything else.
Do you want to shoot your mouth off about that?
Well, I mean, I'm not an investor in any of the companies that are working on it, and I've tried to be neutral because I'm trying not to favor one company over another, but just to encourage anyone that is interested to say that try to give them moral support, and I hope they succeed. The only thing that I am doing on the Hyperloop front is, like, we're holding a student competition, and the student competition is really just aimed towards encouraging students to think about exciting new transport methods. And it's totally cool if they want to, like, do some architecture that's different from what I proposed in Hyperloop. And in fact, the winning team at the student competition that we held earlier this year used a different suspension mechanism than what I proposed, which is I proposed using essentially taking the air that builds up on the nose from the compressor and flowing that through air skis, so that you simultaneously remove the drag from the nose and provide a means of suspending the pod. And that's also something that works well even at supersonic velocities. You can go. It's been demonstrated up to Mach 1.1 in terms of using air bearings as.
But they use something different.
Yeah, basically electromagnetic suspension. The reason I didn't suggest sort of any kind of magnetic suspension is that it's very important that the cost of the tube be minimized. So you really want, because the pod is cheap, the tube is expensive. So if you want to go, say, 400 miles and in two directions, so you've got 800 miles of tube. The critical economic optimization parameter is the cost of the tube. So you want that tube to be as low cost as possible. And so if you do anything that requires action on the tube side, it's going to make that tube much more expensive. So if you use air bearings, it doesn't change. Like, that's real cheap. Yeah, so.
You think this is going to happen?
Yeah, I think something like that. I think something will happen in the future. I think if the companies that are trying to make it happen now, if for whatever reason that doesn't work out, then I think I might do something myself in the future. I don't want to do something. I don't want to sort of front run them. It's like, say, here's this free idea, and then meanwhile I go and do it myself. That wouldn't be nice. So but if a bunch of people, if companies don't try it and it doesn't work out, then I think I'll try to just at least do a demonstration system.